Hey guys, so I'll be talking about one of the basic concepts of pre-cal and calculus, which are derivatives. A derivative is basically the slope of your function. If you take the derivative of a function, then you're going to get another equation for the slope at each of the points of your original function. For example, if we have a graph that looks like this, starting at 0, 0, you can see that it increases, but at a decreasing rate. So it kind of it increases really quickly here, and then kind of gradually flattens out a little bit. If we're talking about the slope of this, the instantaneous slopes of this graph, you can see that right here, at about here, your slope is kind of going to look like that. At here, your tangent is kind of going to look like that. And then here, it'll be like that. So you can see that at each of these points, the slope is going to be different. When you talk about the definition of a derivative, it's usually given by this. dy dx represents the derivative itself. You can see that this actually shows that it's a slope because dy, your change in y, over dx, your change in x, rise over run, which of course is slope. The equation is usually the limit as h approaches 0 of f of x plus h minus f of x over h, where f of x is your function and h is your instantaneous difference. You can see that here f of x plus h minus f of x is your change in y, and then your h is your change in x. And as those 2 points get closer and closer, if we're talking about 2 points from, let's say, here to here, as this point moves closer and closer this way, you can see that the slope between these 2 points will be closer and closer to this tangent line that we drew at the beginning of the video. And basically, that would be a derivative. So it's really pretty simple if you know how to plug in your equation to this formula. In general, you're not going to be using this formula a lot because it just takes a while to solve. You can see that there are a lot of variables there. But usually, if you solve it correctly, you'll have the h's cancel out, and then you can just find the limit of your function.